Alright, so in this video, we're going to talk about um, the difference between Bitcoin and Ethereum. Now, we talked about Bitcoin, blah blah blah, storing transactions, having um, being a cryptocurrency and blockchain. So I think Ethereum is also a blockchain. I think their coin is Ether. Their crypto is Ether. So we know that Bitcoin primarily was created to be a form of an exchange, basically strictly for sending and receiving cryptocurrency, which is Bitcoin. Ethereum, on the other hand, is more like an extra. So Ethereum does the same thing. So basically, let me slow down a bit. Basically, Bitcoin, you can use Bitcoin to send and receive money. It is the act of sending and receiving money that is recorded down in blocks, and they are chained to one another, just like we said. Now, Ethereum, on the other hand, added this feature to their own side, or there's a reason why Ethereum exists. Ethereum is added the same thing. With Ethereum, you can send and receive Ether, and it is recorded in a series of blocks. Now, Ethereum has an extra. Ethereum added something called programs. Now, basically, a program is just like Ethereum added gives you the ability to build. You can now build stuff. It's not just about sending and receiving coin. You can also, let me use the word, send and receive, or send programs, or use programs, or use codes. Now, Ethereum added something they call smart contracts. It's just like, since we can send and receive what's it called? Let me use this analogy instead. Let me clear this off. Forgot to mention something in the previous video I learned. I learned that in a block, you can't change or edit a block. Blockchain is permanent. It's immutable. You cannot edit it. There's a reason why you cannot edit it. Let me explain the reason. So let's say these are 3 blocks. We have their hash. And let's say this, in simple terms, this is hash 1. Or let's say this is hash 201, this is hash 202, and this is hash 203. Obviously, 201 points to 202, 202 points to 203, and the reverse. Now, once this has been sealed, once each of these blocks or each of these transactions has been recorded and sealed, you cannot edit it. And this is the reason why. The moment you try to edit a particular record on a block, the hash changes. So once you tamper with this block, a transaction in this block, the hash can change to 212. And once it changes to 212, obviously you've broken the chain. Because now 201 does not point to 212, and 212 does not point to 203. So you've broken the chain. The only reason why you can be able to get to 202 from 203 is because 203's hash is pointing to 202. So once you edit it, this changes, the hash changes, and this no longer points to this, this no longer points to this. So the only way to actually edit is if you edit this one, you edit this one, you edit all the thousands of blocks. To show you how crazy it is, in Ethereum, a block is formed every 12 seconds. So imagine all the blocks that have been existing for years. Once you edit one, you have to edit every single thing. and you have to keep editing and editing, so it's not feasible. That's basically, it's permanent. That's why anything that is on the blockchain is immutable. You cannot change it. Now, Ethereum now said, okay, since we cannot change what is on the blockchain, what if we start adding agreements in the real world space? If you have an agreement, let's say, I will fetch water for you, you will give me money. That's an agreement. It is signed. Or you can fetch the water and they will refuse to give it to you. That's just how human beings work. Or you want to buy a land. After buying the land, they will sign a contract for you, and they will sign it later. You find out that, okay, well, they cheated you. All these things are agreements. So Ethereum is like, okay, since we have the same stuff that once something is in the blockchain, it is permanent, why can't we add contracts to the same analogy? So they brought something extra called the smart contracts. So smart contracts are basically contracts that are on the blockchain, that are immutable, that are permanent. Once they are deployed, they are permanent, and we know the reason why they are permanent. So somebody will ask, say we are recording transactions. How can we record, or what relates contract with recording? So these contracts are done using program. Obviously, code. You write a code, and that code is the smart contract. If you write a code that once this person gives you money, you must give this person the real documents for a land. That's a code. That is what a contract is. So now, in computing, this blocks a blockchain. Let me use this as a reference. This is a blockchain. We said we are recording transactions. Basically, what we are recording is called something called bytes. Byte is a set of 8 digits. A byte is just a set of a bit. First of all, a bit is like just 0 and 1. Remember, the computer interprets zeros and ones. That's basically it. So we have a bit and a byte. A byte is just a combination of 8 bits. Think. So you can have 10101010. So that is basically what you will basically be seeing on this stuff. So both transactions, or both code, or all of them are bytes. So in a system, for instance, you have something like this. You cannot know which one is program and which one is code. You understand? Both, you cannot know which one is transaction record and which one is a program, because all of them are written this way. So that is how it looks. Then it is during the interpretation now, you can now convert this or interpret this to, you now know that, okay, this one is a transaction and this one is a code. That's how it works. So they found a way to put instead of just putting records of transactions, they now put programs inside it. And I'm going to briefly explain how they added a program to something like this. So this is how it works. In a normal day, if you want to send, let's say, send this person, Mr. A, is sending, same example, 5 BTC to OX224 from means his own key, his own address, from OX442. He will now seal it with his private key. Private key is just like, okay, this is my password. Use it to perform this transaction. Now, there is a normal, if you go to a bank and you want to fill a form, or you want to, in your bank app, if you want to transfer, there's a place called remark. They'll put a box, and maybe you add like a narration of what the transaction is for. Maybe you can write money for clothes or something, just a remark. The same way in coding, or in how do I put it? The format for writing a transaction, just like this. You also have, there's a column called data. So the data is just like a remark. So most of the time you can leave it empty. You understand? You can leave it empty. And remember we said if you want to initiate a transaction like this gets broadcasted to all the nodes. I don't know if you remember from most of the videos, to all the nodes. And then they will now check whether it follows the rules. So this is how it works. When you have a function like this, they will do it and they will now add it to that block. So now, Ethereum, how does Ethereum now send a program? This is how they do it. You see this column that is empty? That's what they make use of. Let's say you write it, after writing your code, your smart contract, the program, the code, what you want this thing to do. You obviously know how code works. It's just like you write in the code that once A does this, B does this. You now send it this way. You write 5 BTC. You add, I think, a fee or something to now from your wallet OX442. The 2 now you leave it empty because you are not sending any money. You leave it empty. Then in the data, they will now add that program. Remember we said programs are just bits or bytes. They will now add the program 10101000, something like that. Now, when this gets to a node, let's say okay, adjust this a bit. When this stuff, if this one gets, let's say this is a node. A node is like a computer. A node that has blocks before. When this, and remember we said something about having a mempool. When this node receives this stuff, it's very plain. It knows what to do. It will just write it down in its mempool. But in this case now, the node receives this. It interprets this transaction, sending 5 BTC from this wallet. We'll check. Does this wallet have 5 BTC? Yes. Okay, where are we sending it to? No address. This is where they will now have to go and check the data. Let us see the remark that you sent. Okay, what am I supposed to do with this transaction? They'll now see that, oh, we added a program, we added something. They don't really care what it is. We added something into it. So what they will do is this node now will create a new wallet. They will create a new wallet. Let's say OX111. So now they will now store this data under this wallet. I don't know if you're getting what I'm saying. 0000. So they will now record it. This is now the record they will now add here. So whenever you want to run this program, you will remember now, this is obviously for it to be able to send, you need to have an app or something that will enable you to input the UI, all those things on your phone. So after sending this this smart contract and is recorded, they will send back the address your program lives on. So whenever you want to tamper with, or whenever you want to activate or kickstart, or what word to use, initiate this program, whenever you want to carry out a transaction, this is already written and stored in the mempool. And remember the process eventually to be added to the blockchain. Whenever you want to tamper with this stuff, with your program, you will access your program through this address. So whenever you want to initiate your program, you will now make a transaction. You say 5 BTC from OX442 to OX111. So now when this gets to a node and they are checking it, okay, this person, does he have 5 BTC pass from, okay, this is the wallet address, to, they will now look inside this wallet address. They will now see that, okay, this wallet address has code, not a location. They will now look at this code. Okay, the code said that I should send. They will now check those conditions and implement it. So that's basically how they were smart enough to put a code inside a record. So now Ethereum is not just does not just have Ether, a cryptocurrency which you can send and receive. They have smart contracts. Now, And the reason why these smart contracts are permanent and reliable is because this smart contracts has been added to the blockchain. Remember what we said about the blockchain being immutable. So that is the reason why. Now, maybe in the next video, I'm going to explain how Ethereum works. Just like Bitcoin, we talked about how Bitcoin has proof of work. Ethereum has something called proof of stake. It works differently from Bitcoin. So we're going to explain that in the next video.